In my opinion, there are a few things more rewarding than doing a little bit of astrophotography, and especially if you're a photographer who has an interest in the night sky or nature, I would highly recommend you do it. It's very much like film where it's kind of a delayed gratification. It really just opens up your eyes to what's above you in the night sky, which is such a rewarding thing. Now, if you've ever done landscape photography or nightscape photography, you probably have done it with a tripod and a camera, but you're gonna hit a threshold eventually in terms of detail and color and signal. And once you hit that threshold, this is gonna be the best answer for you. It's a star tracker. This is the Skywatcher Star Adventurer. Now, I did do a review on this star tracker and we'll link it above. It's a great way to get started with astrophotography. So if you haven't seen this before and you need to learn a little bit more about it, check this video out and it'll give you a full rundown. If you are a little bit more advanced, then you may wanna get something like what's called a German Equatorial mount. Now, it's very similar to a star tracker, except it's gonna connect to a computer. It can hold much bigger payloads, giant telescopes, and it's much more sophisticated, so it requires a bit of a learning curve. But if this is more your style, I did do a video going over a deep sky astrophotography rig just like this with all the components so you can figure out what it is that's gonna work for you when you build one of these rigs. So if that's something you're interested in, feel free to check that video out. We'll link it as well. But tonight, we're gonna be focusing on the star tracker. So we're gonna show you how to get this all set up. I'll give you a few pointers, hopefully it'll help you out. And we're gonna do a little bit of astrophotography tonight. There's our target right. All right, so here's the components of a simple wide field astrophotography rig. So you can see right here, we have a tripod. You're gonna want something as sturdy as possible. We have this Skywatcher Star Adventurer here. My old Canon T3i that's astro modified. If you guys want to learn how to astro modify a camera, I have a video on how I did that here. So feel free to check that out. We'll link that as well. This is a ball head, whatever this thing is called. It's an intervalometer. And then this is a battery adapter. So it's a dummy battery that'll plug into the camera so I can actually plug this into the wall. And then of course, don't forget your memory card. All right, so let's get into setting up. The first component of setting up your astrophotography rig is gonna be your location. Now, you wanna make sure you're on pretty solid ground and you wanna make sure you have good view of the sky. I know that sounds obvious, but it's kind of tough when you're next to a building or if you're next to trees or if you have a giant street lamp in your yard, you may want to avoid that. So what we're gonna do is we're gonna shade ourselves off from that with the garage. That way we don't have that orange cast. That's a sodium light and it's pretty bright. It's not shielded. If we let that hit the lens, it's gonna give it a really white kind of cast. So we wanna avoid that. So once you find your spot, now we just set up the tripod. And with tripods, the sturdier they are, the better. This is a carbon fiber tripod, but to be honest, use whatever tripod you have. The only prerequisite is that it can handle the weight. It's not gonna tip over. And also it's gonna need a 3/8 adapter. So you need to make sure that the tripod has that kind of screw because it'll mount up to the base plate of the Star Adventurer. So we got the 3/8 here, 3/8. We'll screw it on. So now you can see right here, there's a bubble level and we're gonna use that to obviously level this, but we'll wanna make sure that we're facing this towards the north, okay? The reason we're gonna do that is because we need to polar align this. So we need to point this at Polaris, the North Star. So north is this way. So we're gonna point the base that way and then we'll get it all leveled up here. And okay, that looks pretty level to me. This is the first version. There is a couple newer versions of the Star Adventurer now that have like Wi-Fi capabilities and cool things like that. But this is just the OG one. So this is gonna mount right into the base. All right, so now we're all level here. And if you notice right here, there's some numbers. Now this is called the latitude adjustment base. This knob will change your latitude here. Now an interesting fact about latitude is that it's actually directly tied to the North Star. Depending on your latitude, like right here, I think we're at 45 degrees north latitude. That is going to tell you what the angle of the North Star is in relation to the horizon. So you can draw basically a 45-degree angle to the North Star based off of a 45-degree north latitude. So that's gonna change based on where you are on the planet. If you're further south, you're gonna have a lower latitude. If you're further north, you're gonna have a higher latitude. If you go all the way to the North Pole, you're at 90 degrees north, and the North Star will be perfectly up, creating a 90-degree angle. Now we're a little further south, so we bring that angle down to 45. Kind of a cool little fact. So the next component here is the ball head. I'm gonna build this up right now while we still have light, so it's just easier to see. But you will need to take this off to do a polar alignment. But to start, we'll put the ball head base on, and then we'll grab our T3i. So next thing we'll do is put the battery in, get the power to the camera. I am using a dummy battery, like I said, but you can totally use normal batteries. I just like to use this because then I don't have to worry about swapping batteries. And then the next component is our intervalometer. On the T3i, it's just a remote input here on like a 3.5 millimeter jack kind of thing. So now that's basically everything we need to get it all set up. This Star Adventurer is battery powered, 4 AA batteries. That's nice because then if you're traveling, you can swap them out or whatever. But there is actually I think there's a power, yeah, so DC 5-volt USB. Looks like it's a mini USB. So you'll have to get one of those, and then you can plug this into power. And then since we're here, this is the auto guider port. If it's something that you aren't familiar with, it's basically just telling the mount to nudge back and forth to help with errors. So you can use auto guiding with this, which is kind of nice, but we'll save that for another time. All right, so if you want to come around to the front here, I'll just show you the panel. And this is like so screwed up. I'm sorry to everybody on the internet. This is not what it's supposed to look like. My label is so messed up right now. Right there, you can see that it looks like a star. That's star tracker mode. So that's what we'll use to track at the pace of the stars. And then you do have a couple other ones. There's like solar tracking mode, lunar tracking mode, 0.5, and then a couple like time-lapse speeds. So you can use this for time-lapse, which is kind of cool. At this point, we're pretty much ready to shoot, but we obviously have to wait for it to get a little darker. The next step from here is gonna be polar alignment. And we'll talk about that now, just so that you guys can actually see me a little better. And then we'll actually walk through the process of polar aligning as we do it. So I'm gonna take this off again, even though I just put it on, because the Star Adventurer here has a polar scope here. So you can see there's a viewfinder right here. The North Star stays in one spot in the sky, but it doesn't stay perfectly in the same spot. It actually traces a really small circle in the sky as the day goes on. So inside there's a reticle with hash marks, and at any given time of the day, it's gonna be at a certain point on the clock. How do you know where it's gonna be on that clock? You know, an app is kind of the common way to do it nowadays. I have an app called PS Align, and my phone offloaded the app, so I won't be able to show you this until I cut, but essentially, this will show you what to look for. So once I get this downloaded, I'll show you. Okay, finally got it downloaded. My phone is always full. Here is the app. I don't know if you can see this very well, but you see how it's kind of like a reticle, and you can see down here, there's where the North Star should be. So you're gonna wanna get the North Star as close to there as you can. Now, when you're shooting really high magnification, big telescopes, you wanna get this perfect. You don't wanna stray away. You wanna be perfectly level. You wanna be perfectly polar aligned. But the beautiful thing about doing wide field is that it's a lot more forgiving. For the sake of practice, I would always make sure that you are perfectly polar aligned, because this is a skill that's gonna carry you up through the ranks of higher level astrophotography. So make sure that you really take time to get your polar alignment right. It's a little bit of an art. There's not really any analog that can give you experience with polar aligning other than doing astronomy. Once you learn how to do that, you're officially an astronomer, if you know how to polar align. But in the meantime, we'll just wait for the sun to set, and then we'll go over polar alignment, focusing, and framing up your target, and then we'll start shooting. There's a little rabbit over there. Take a look. Buddy, do you feel safe over there? We'll just leave you there. All right, it's time to polar align. Got a beautiful waxing crescent moon. Got Jupiter over there. Looks like we've got a little bit of cirrus cloud action. It's hard to predict the weather when you're next to Lake Superior, so. In fact, while we're talking about it, If you ever need a good weather app for astronomy, I highly recommend Astrophotography. I won't be able to actually show you the polar alignment process here, but once again, we're just gonna go into our polar align app, take a look at where we're at, so you can see now it's changed from last time. You see how it was up here and now it's down here. That's where we wanna go. We wanna go, it just happens to be right in line with that reticle. So I'm gonna take a look through the scope, put this North Star right there. If you can manage it, try doing your polar alignment right at dusk, right after the sun sets, because then the sky glow is gonna help you light up the reticle. Since it's a black reticle, looking at it with a night sky can be really tough. So try doing it during dusk if you can. I'm gonna get down on a knee, take a look. Polaris is a part of Ursa Minor, the Little Dipper, the little bear, whatever you wanna call it. I don't see it yet, and I'm just gonna kind of move left and right until I can see kind of a bright star. Okay. I'll use my latitude adjustment bolt, which is this guy, to move it up or down based on where the North Star is. These two bolts are gonna be your left and right adjustment here. So you'll use these to get your fine adjustment, which I'll do right now. And I forgot to mention, since this actually rotates, the reticle itself rotates with it. So you're gonna have to put it upright so you can start doing your polar alignment correctly. Like I said, since we're gonna be doing a wider field at 50 millimeters, we don't really need to worry about it being super accurate. But I got it right where you saw it on that reticle. It's in the exact spot. You know, the more accurate it is, the better. If you're a little bit off, you might get a little bit of drift or something like that. And that's only gonna make your image worse. So try to get it as close as you can. So now that we're polar aligned, don't touch it. As much as you can avoid touching it is gonna be better, because with a smaller, lighter rig like this, even just a small tap can move it out of course. So be very mindful of that. Now we'll get the camera put on. So being careful not to bump it too much or to have your camera fall on you. This is your clutch, so we'll tighten this up so that the camera doesn't go flying. So now we're polar aligned and we have the camera on. So we'll go ahead and flip it on. That's star mode, even though it doesn't look like it. Our next order of operations is gonna be getting our focus. Getting focus can be a little tough if you're using maybe like not a very light sensitive lens. And it's also tough if you don't have very good, you know, stars to focus on. But I'll show you a technique here that helps me get a good focus. On your camera, you should have a live view mode. So on the T3i, it's right here. So we'll click this, and then you can see now we're kind of viewing the image in real time. It's live, guys. So you can see here's the light, the lamp. So we're pretty focused already. So that's one thing that you can do, is you can use like a mile marker or whatever. You can use an object that's off in the distance to focus it, and you can magnify. So I'm gonna magnify. And so that's one way of getting focus. You can just focus on like a light pole really far away or something like that. But if you don't have that, you're gonna wanna find something really bright in the sky. If you look over here to the right, you might be able to see a bright star-looking thing over there in the trees. That's actually a planet, that's Jupiter. And we're gonna try using that to get focus as well. Now it's behind the trees a little bit, so it may not help us. All right, so we'll zoom in. You can see the bright dot right there. And we'll pull the focus ring until, okay, that looks pretty good. In fact, it looks like you can pick out a few of the Galilean moons of Jupiter here. So you can see there's just a little dot there, and there's a little dot here. Might be hard to see on camera, but those are actually moons of Jupiter. And they're named the Galilean moons because our buddy Galileo discovered them. So now it's just a matter of finding a target and doing a test image. Now this is where you do need to know a little bit about astronomy to find your targets. And so I really recommend you study star charts, get out under the night sky, see what there is, get familiar with it all. That is gonna make your job a lot easier when you're trying to find things, especially when you move up to higher focal lengths. It's gonna be pretty unforgiving. I mean, when you're shooting at 1,000 millimeters, if you're trying to shoot something that's tens of millions of light years away, there's not a lot of margin for error. With the intervalometer, this is going to be kind of a key component because it's going to keep your hands off of the rig. You can also set up intervals. So you can tell it to take a certain amount of pictures in a certain amount of interval time, whether it's 1 minute, 2 minutes, 3 minutes. You can set exposure time. So this is going to be how we actually continue our imaging sequences with an intervalometer. This first level here is the self-timer. So that's gonna give you a delay when you press the shutter. So we'll just do like a 5-second delay so that when we start our imaging sequence, we give it a little bit of time so we can get out of the way and let it start. Now in bulb, we'll need to choose our exposure time. For what I'm gonna do here, I'm gonna just say like a 2-minute exposure. So we got 2 minutes, 0 seconds. Your interval is gonna be how long in between each exposure, okay? So if you have a 2-minute long exposure, you're at least gonna need 2 minutes on this interval so you can get your exposure in. So we'll do 2. But what I like to do is just give the camera like 10 seconds at least in between each picture just to let the sensor chill for a sec. So we'll set our interval to 2 minutes and 10 seconds. It just gives it a little break and then gets right back to shooting, so we're not wasting time. Then we have number, which is pretty obvious down here. You can set it to like 0 on this one, which will just keep going forever. Or you can set up a certain number if you have a specific exposure time, like an hour or 2 that you need. You can do the math on it. 2 minutes times however many to get 2 hours. And then that's just the beep. You can turn off the beep. So that's how you set up an intervalometer. Once everything's good to go, oops, that's the shutter button. You press this start button. So now it's counting down. And then the camera's gonna start shooting. With astrophotography, it is a lot of setup. And then if you've done your due diligence, it's just a matter of waiting. We just need to capture photons. When we take pictures of the night sky, we need a lot of exposure time. We need to be able to see really dim things, so we need to gather a lot of light. So in order to do that, we need to take multiple pictures, right? Really what we're doing here is taking a time lapse of the night sky, but we're gonna be tracking the night sky instead of just watching it go by. Over the course of the night, we'll gather more and more and more light with every exposure, and then we'll go in and we'll stack it all to get more signal. Now, that process we'll go over in the next video. Just know that the name of the game in astrophotography is exposure time. That is the biggest factor that's gonna change if a picture is really good or really bad. You don't need a giant telescope or even like, one of these star trackers. You can get really good signal if you're constantly taking pictures of the same field of view because you can stack that signal against the noise. It's called your signal to noise ratio. You could do an hour, 2 hours, 4 hours, 8 hours, 12 hours, whatever you want to do. The more exposure time you put in, the more faint objects are going to show up. So it's going to be more clear, you're going to get rid of noise, and you're going to get more signal. So the more the better. A couple of technical things there just to keep in mind. So we're going to let this run for a little bit, and then we'll come back and check on it, and I'll give you a couple more pointers for how to continue shooting. And yeah. Okay, it is quite a bit later than when you last saw me. It's about midnight. We're just waiting for those cirrus clouds to pass, and it looks like they have. But really, we were waiting for Orion, and Orion doesn't rise until about midnight. So we had to wait a little bit for that. It's gotten quite a bit colder. There's frost everywhere, but I don't mind a colder night. Typically, it's better for your camera to have colder temperatures because your sensor in the camera is going to get hot as it continues to take long exposures. The hotter that your sensor is, the more noise it's going to have because there's something called amp glow. It's just the heat coming off the camera. That's going to make your image just noisier. There's actually people who have created Peltier coolers for their sensor where they put kind of a heat sink on the back of the camera and keep it cool. That's an experiment that would be really cool to try on the T3i. And you'll notice I actually put something on the lens here, and this is a dew heater band. All this does is it warms up the lens itself so that it doesn't get any condensation on it. Dew is a really big problem. As you can see with all this ice and stuff, there's just moisture everywhere. So we want to keep moisture away from the lens. So we've got the dew heater band, got the tracker on. So let's turn on the camera. Exposure settings that I'm doing here, I'm going to stick at f2 just to get as much light gathering ability as I can. You can stop down, it'll probably give you a sharper image, but I'm going to start with f2 for now. ISO 1600, I used to do 800 on the T3i, but I do 1600 now. There is a rhyme to the reason here that I'll explain in a different video, but it really just has to do with your sensor and what kind of dynamic range it has. So we'll talk about that later. For exposure time, I just kind of experiment based on the target. There are certain targets that are going to be brighter, some are dimmer. So it's a bit of a trial and error game, but we want to just take a look at the histogram when we get there. So there's our target right there. That's Orion the Hunter. You can see those 3 stars in the middle. That's Orion's belt. Just below it, there's kind of a little glowing thing right there. That is the Orion Nebula. And that's the closest star-forming region to the Earth. So this is Orion. This is what we're going for here. And at 50 millimeters, we can actually fill the frame with the whole constellation. So now we're going to hop into live view mode. If you see there, we have Orion framed up right there in the center. We've got Orion's belt. There's the 3 stars. If we turn over here, that little guy, that little fuzzy thing, that's the Orion Nebula. And that's just one of the nebulae in this entire constellation. This whole thing is just covered in hydrogen alpha nebulae. That's basically where stars are born. We've got it framed up. We've already focused. We're looking pretty sharp. Now we have to audition some exposures. Earlier I was talking about 2 minutes. Let's just start with 1 minute. I'm gonna just time it manually and you can hold it down. So I'll press this. Can lock it. And we're gonna let this count off. Wait till it gets to 1 minute. Does look like we still have quite a bit of haze right now. You see that? Well, everything is about as good as it can be, so I think I'm going to start the imaging sequence and hope for the best. Go down here, timer. Let that start. And we are imaging. And the reason why I say hope for the best is not because I don't have confidence in what I'm doing. I think we have a little bit of condensation inside the lens. That is a pretty big issue, but I have a dew heater band on. It's clear out. I'm just gonna let it run. We'll see what happens. I really like the composition that we have, so rather than changing lenses, I would just like to get an imaging sequence going. I'm gonna let everything take its course. Maybe the dew heater band will help dissipate some of that excess moisture and give me some clearer images, but until then, we're just gonna let this thing rip away like it's doing right now. All right, folks, well, it's about 5:40 in the morning. Orion is setting behind the horizon here. And so that means we're basically all wrapped up with taking our light frames. Light frames are also known as subframes, but this is where you gotta dig deep after all the shooting and being up all night. You still have to get your calibration frames. Your calibration frames are as follows. You have your dark frames, your bias frames, and your flat frames. So those 3 combined with our subframes are gonna make the full image. Let's walk through that really quick and then I'm gonna go to bed. So first thing we'll do is we'll take our bias frames. Now to do that, we got to put our lens cap on. Once the lens cap's on, we're going to put the camera in shutter priority mode, which is TV on Canons. And then we're going to put this to the quickest shutter speed it can go, as fast as it can go. This one is 1/4000th of a second. Take 10 to 20 of these pictures. So with the bias frames done, next thing we'll do is flat frames. Flat frames are basically like a profile correction for the lens. It'll take away vignettes. It'll also take away any dust spots that are in your camera. I've seen people use a white t-shirt stretched over the front of the lens, looking at the dawn sky glow. What I do, since I typically am doing this at night and I don't want to wait until the morning, is I will use a laptop, put on a white screen, and then cover the lens. Make sure that it's perfectly flat, even across the lens, and then take another, 10 to 20 of those pictures in aperture priority mode, so we can make sure that the camera is still at the same aperture we shot at. The last type of calibration frame is your dark frame. Take a dark frame, you're just gonna take the exact same exposure that you would with your light frame. Only difference is you're gonna put your lens cap on. Dark frames help with sensor noise and eliminating the noise that we don't want, giving us good signal. It kind of cancels it out. So those are your main calibration frames. You have dark frames, bias frames, and flat frames. And then you have your sub frames, which are your pictures. All right, the sun's starting to rise behind me, so that's about it, guys. That's how you take pictures with a star tracker. Hopefully you found some helpful tips here. If you have any questions, just leave them in the comments. I'm more than happy to answer them. Next video, we'll do some processing of all the data that we just captured. So we'll show you the process of integrating all of those calibration frames, getting all of the images stacked, and then bringing it into an editor to edit the picture and make it something shareable, which is a really exciting part of it. If you stayed this long, I really appreciate it. Hope to see you again. But until then, keep looking up. Got some tracks in the frozen gravel. Looks like we've got deer and some sort of canine, maybe a wolf.